I'm wondering, we are very shortly ahead of go live, but it would be really great if we can take like questions from the folks on the live stream. Is there any way that we can build that into this?
I think we have a chat on YouTube, if I'm not mistaken.
Okay, maybe I can monitor and see if we have time to do a Q&A, but I've never done the YouTube live stream, so let me pull that up and see. Okay.
Ready when you are, guys. Let me know if we can go live. Everyone is good?
Let's do it.
It will take about 10 seconds until we're actually going to see that. So I think. Oh, we are live.
Fantastic. Cool. Let's get it kicked off. Thank you everyone for joining the live stream today. We're super excited to have this fireside chat with folks from the Blox team, ConsenSys team, and the Ethereum Foundation. And today, just for a quick note on the agenda, so we want to spend some time talking about what SSVs are and really what their value add is for the community and the Ethereum network overall. And then we want to get a little bit more tactical and have a conversation about what the different use cases are that SSVs can be used for, and really make this an interactive conversation with everyone in the community. So without further ado, let's get it kicked off. Cool. Maybe we can do like a quick round of intros of everyone on the call and just give like a quick overview of the people attending. My name's Mara, dialing in and working over at BisonTrails, and I'll be moderating today's fireside chat.
I'm Alon. I'm the CEO of Blox, and
Hello everyone, my name is Aditya. I work with the Ethereum Foundation on the ETH2 spec team, and I mostly work on ConsenSys issues.
Yep. Hi, I'm Dankrad. I'm also on the ETH2 research team at the Ethereum Foundation.
Hey everyone, Collin Myers. At ConsenSys, I primarily focus on a product at ConsenSys called Activate, which focuses on fair staking, amongst other things. And I've recently spent quite a bit of time on different topics of ETH2, and happy to be here and happy to add value where I can.
All right, perfect. So my first question, and this kind of goes out to everyone on the panel today, what are actually SSVs? What do they stand for, and what are they trying to solve for?
who wants to take that?
I can take that. I guess we should address it to people, but so SSV stands for Secret Shared Validator, and the idea is that instead of running a validator on one machine, you can split your secret over several different machines that can be anywhere in the world as long as they're connected to each other. And the key can be split in such a way that's called a threshold signature, where you have a certain threshold, and below that threshold you cannot create, like if fewer than a threshold try to cooperate, they cannot create a signature together. But once they exceed the threshold, they can sign something. And this is a very nice way in which you can increase both liveness and security, because you can ensure that even if one of your machines, or depending on how many you have, several of your machines get compromised, people cannot get your key and they cannot sign invalid messages and thus get you slashed or anything like that. But on the other hand, you can also tolerate some of your machines being offline if they are fewer than you need to create a signature, and in this way you can get both better security and better liveness for your staking.
Yeah, there's a lot of application and interesting kind of effects going from that into different use cases, but also just plain old better infrastructure for most use cases, more robust and fault tolerant.
So Alon, you just touched a little bit on it there, and I guess like I want to drill a little bit deeper on this question. So why exactly do we need this? And what specific value add does this provide to the ETH2 network overall?
So I think that the two main concerns for any setup or any use case for staking could be enterprise, could be pools, could be just home staking. The two main concerns, of course, the first one is slashing, which is getting penalized and force exited from the protocol. And the penalty is pretty significant and will be actually higher, I think, in the next hard fork. And the second priority, of course, is being online and actually earning the rewards. Those are the two main concerns for almost any setup for staking. And so I think that SSV enables to improve significantly on those two fronts. When you have several different nodes or machines running the same validator in a secure way, of course, slashing becomes much harder, both in terms of an accidental slashing, but also from an attack. And of course, performance should get better because you have a more robust system with much more redundancy. And so I think that's an important improvement. Yeah.
So you touched a little. Yeah, go ahead, Collin.
Sorry, I'm on a big delay here from when I apologize. My thoughts on it are kind of a bit more high level, and what I've come to realize is that it does a lot for ETH2, but it also introduces this new call it node setup configuration possibilities inside a blockchain itself. And we'll get into that more in the use cases, but it allows for any validator who is on the ETH2 network to create an active setup. Today, where that is really not the case. So it actually involves a larger innovation inside of how validators manage themselves and how they can configure their nodes on the network. I think it's something that'll far extend beyond ETH2 and get used across all different blockchains. Not all different blockchains, but blockchains that need it in the future as well. So it's less about ETH2 for my eyes and more about innovating the way that validators can set up their node clusters.
I think that, and even extending it to maybe the philosophical, when you have an SSV setup, you can actually diversify the actual nodes implementation you're running on. So to anyone who's that a concern for them in terms of decentralization, in terms of just plain security, that's a possibility which opens up much easier in a much easier way using SSV, which could be crucial.
Maybe one more thing to add there. The slashings that we have seen on the ETH2 network, at least up till now, have been because people are trying to build redundancy into their validator client setups. And running the same keys on a different validator client on a different node is the wrong way to do this, just because there's a high risk that both of your validators become active at the same time and you get slashed. So SSVs are in some sense the correct way to build redundancy into your ETH2 nodes, especially for validators. As as you all know, the ETH price has gone up a lot, and 32 ETH is now become a big investment. And obviously, stakers want to protect their investment. At the same time, they want to have maximal performance out of it. You don't want to miss attestations. You don't want to miss proposing blocks. So SSVs really help with the performance and security of a validator setup.
So what we've kind of discussed, and I really do want to drill in here a little bit more, but one of the critical areas, I guess, that SSV is really trying to protect against is different types of potential modes of validator failure. And we kind of touched on it as part of this conversation, but really the main, key aspects for this are really liveliness and security. So I think from that perspective, Aditya, you actually put out a really great post on this quite a while back. So I'll hand this question over to you, but can you dive a little bit deeper into what specific potential modes of validator failure SSVs are trying to address?
Right. So as I said earlier, SSVs help with the security and performance, improving both of them for your validator setup. So by performance, what I mean is that you want your validator to not miss any of the duties that it is assigned. Every time it misses a duty, your stake goes down by a bit. So you don't want that happening. You want to always get the reward for duties that you are assigned. And potential reasons that you might miss your duty are internet connectivity issues, your hardware failing, bugs in the ETH2 software that you're using to run your validator. And all of these can lead to just missing a duty. So SSVs build some redundancy into your validator setup, wherein you can avoid or at least reduce the chance that you're missing your validator duties. And the other thing you want them to do, the other failure mode that you want to protect against is key compromise or security failures, wherein if you are using if there's a single place that your entire ETH2 key, validating key is stored, and that gets compromised, then basically your entire validator is, it's up in the air. Someone has control of your keys and can get you slashed at any time. With SSVs, it's kind of for our listeners who are Harry Potter fans, it's a bit like Horcruxes, where you're splitting your soul into multiple pieces, and unless someone has all of them, or in the case of SSVs, a very high threshold number of them, they cannot attack you, as so to speak.
Really love that Harry Potter analogy there. So in terms of, since we kind of are talking now about, one of the main components here, obviously being, distributed key generation and the ability to combine keys in line with threshold parameters. Let's talk a little bit about the different components that actually, comprise an SSV configuration. And I think I'll ping this question over to you, Dankrad, to kind of get us kicked off here. But I think our listeners would love to hear a little bit more about how an SSV standard configuration is set up.
Right. So what you do is you use a so-called BLS threshold key, which is you split up your key such that it's on a polynomial, and any shares more than the threshold are enough to reconstruct the actual key. And the nice thing about BLS is that this key is much more powerful than that, because it doesn't just allow you to reconstruct the full key, which is nice, but it actually allows you to sign something without reconstructing the key. And that is really that's the important property here, because otherwise if we had to reconstruct the key, the whole thing would really suck, because then you don't get this huge security advantage. But instead you can then give everyone something to sign, and they can sign independently, and then you can put all these different partial signatures together and reconstruct one full signature for the key. So that's BLS threshold signatures. That's one key ingredient, but the lucky thing, the great thing is the way that they are designed. And that's actually kind of why we chose them for ETH2, is that this piece is really easy. Like this is almost completely trivial and can be implemented using a BLS library in just a few lines of code, basically. So then the next two important components that need to be added to this is you need a key generation. Somehow you need to get these key shares, and there are different algorithms that that allow us to do such a distributed key generation. This is actually not necessarily like an absolutely essential component, because you can in certain settings say, well, I'm okay if I generate the key myself and I just then split it up. Like it seems a bit less safe, but actually for our application, in some cases, for example, if you just want to run your validators at home and you want to be a bit safer and split them up on 4 machines, then I mean, that's kind of okay. But still, like we can improve that using a DKG, and the DKG is essential for other settings, such as when you want to share your key trustlessly, because you have like these people you met and you want to run a validator together. But yeah. And then the final component that's important, well, okay, the final, I guess, like cryptographic component, let's say it like that, that's essentially is so-called Byzantine fault tolerance. So you need a system to decide what you want to sign. And because it's all nice that you can sign things and put those signatures together, but it's also important that everyone, at least all the honest ones, all the honest nodes that haven't been compromised, so all the online nodes, will be able to decide that on the same thing to sign. So that's why we need a BFT algorithm. And then I guess the way we implement these, I guess you could say that is also a component, is we will add a new piece of software, that's the SSV node, that in essence puts these together and adds like a protocol for these nodes to speak to each other. Obviously, that's essential, and also the SSV nodes need to be able to speak to both the validator client, which is a piece of software that we have that contains keys, and to the beacon nodes, which is the piece of software that every ETH2 client comes with, that actually like implements the piece that, yeah, builds the peer-to-peer network and validates blocks and everything.
Maybe from the perspective of users, what it might look like is currently we have 2 pieces to an ETH2 node, which is the beacon node, which handles all the networking and peer-to-peer stuff, gossip stuff, and everything like that. And the validator client, whose sole responsibility is managing the keys and signing on essentially things that can't get you slashed. And with SSVs, there will be this middle layer that comes in between the beacon node and the validator client. And from a user's perspective, you just have to kind of plug in this SSV component, and it should take care of everything for you.
Yeah. I always describe it as a sophisticated multi-signature wallet or signer with a consensus layer. And so maybe that's easier to digest. Yeah.
Great. I really like the diversity and explanation and depth here. Now that we've kind of spent a little bit of time talking about the different components that comprise an SSV configuration, I'd actually love to draw a comparison. So how does this really differentiate itself from like the architectural setups that we're seeing today, and what are really the benefits of that before we dive into discussing different use cases for different user groups?
Yeah, I think that so current setups, and it varies depending on the service, depending on how you set up your service or setup or any of kind of those things around, you know, from home staking all the way to pools. But what the kind of the things that is common between all of those setups is you always have one signer, one validator, basically. A validator has the function of signing and slashing protection. And you always have just one of those components, unless your setup is not secure, in which case you might have more, but you're risking slashing. In a secure setup, you always have one validator component, which can hold a few validators in it or a few private keys in it, but you always have one component. So if that component fails, then you stop validating. If that component fails in staying up or online, or if that component fails in terms of slashing protection, then you can risk slashing. And so what SSVs try to do is really take that one component and split it up. And so once you split it up between different, might be different entities, different machines, different cloud providers, different, basically any kind of diverse vector you can take it from that, then you greatly reduce those two things, uptime and slashing protection. You also have maybe benefits, and we'll probably talk about it in the use cases section. You also have the benefit of, let's say, easier maintenance, because, you know, if you have a threshold signature, you can take out one node, update it, place it back online, go to the next one, update it, and so on and so forth. If you're a really, really big custodial, which has a lot of validators, you know, you can split up those keys to different entities, different cloud providers, and so on. So I think that's the biggest benefit I see. Just taking that single component, which is common throughout all of the setups, and just splitting it up into different nodes, and that way you create robustness.
Great, thanks, Alon. And I think with that, this is actually a really good segue to start having a conversation about how different people at home and for their business can think about integrating SSVs. So I would love to pivot the conversation now and have a little bit of a discussion around the different use cases. And the key areas that we're going to be chatting about today is, you know, how can an SSV be used for an at-home validator, your standard hobbyist who runs their own infrastructure, for different staking pool providers. And thankfully, we have a few experts on the topic on the call today. And then for infrastructure providers, so your general staking providers in the space and how they can leverage this type of solution. So maybe we can get it kicked off with the first. And I think one of my main questions is, how can this kind of configuration benefit an at-home validator? And I would love to have a discussion about kind of the economical implications of this type of implementation. So maybe for the first part of the question, I'll ping this over to Dankrad, and would love to hear what your thoughts on this are. And then I'll ping it over to you, Collin, since you've been doing some work on the economic analysis for this.
Yeah, so I mean, I think like the way I would say this is like SSV is kind of like, is a new tool in our toolbox for like that allows you to like, yeah, create better validators if you want to use it, and you can actually use it in many different ways. So like you can adapt the threshold. You can think about like, do you prefer liveness or security? When you stake at home, it's probably actually security that you're more concerned about. But yeah, so there are these different variables, and like the way you can use it in at-home staking. I guess it's quite unlikely that at home you want to run several beacon nodes. Say like you don't actually want like, so the improvement in terms of liveness you can get from it is probably in this, if you want to use it purely at home, is minimal. But what you can do is you can distribute your key over several other machines. You can like, or yeah, even just 2, 3, depends on what you want. And you can make them independent in hardware and software. So now it becomes very, very unlikely. You might be like basically concerned that the machine that you use to run your beacon node on might become compromised. But that risk almost completely goes away once you split your key over several machines that say have like only very, very minimal software installed and are only accessible through like a network connection that itself isn't directly connected to the internet. So basically, you can increase your security by a lot. The cost is obviously that of adding those extra machines and running them. But I mean, I currently, well, obviously, like Collin wants to comment on this, I have the feeling that already now this, if you are more security minded, is becoming an interesting option at the current prices that are involved, even if you're just running one or a few validators.
Yeah, and even so, we've done some economic analysis, and we've built a model for everyone that's inside of the normal ETH2 calculator. It's an SSV tab, and it basically allows you to simulate like your cluster size. You can choose from between 4, 7, or 10, which are the fault tolerance levels of IBFT. And today, to Dankrad's comments, with Ether at the price that it is, if you're at home running one validator and you're using a $500 machine to do so, it is still quite profitable for you. And it's between 6 and 10%. It just depends if you go up, from 4 nodes or 7 nodes or 12, 10, or whatever your progression is. But earlier in this, when the research started, the price of ETH was much different. So it's kind of been this ongoing battle with the research here to ensure that it's a solution that at-home validators can use and it's feasible for them to do so. Because everyone is always cost conscious, and obviously now as ETH has got more expensive to even participate, we don't want to build a tool that at-home stakers can't use, because that's the most important part of Ethereum, and that's how it will achieve its strength, is by having millions of people around the globe hopefully validating inside their house. So today it's been progressive for that, and the at-home validator segment inside of this has gotten a lot more rosier, and we're actually quite excited as part of kind of the testnet philosophy for us, including at-home validators inside of that is like a core component, is still profitable, because there's a lot of people that like to complain about the returns of ETH2, just because relatively, what's happening in the industry is there's all these yields being thrown around and all these incentive programs to get people to participate in things. And, we've been battling this ongoing debate of should I even use my ETH to validate, or can I get more value with it elsewhere? So things on the economics front for the at-home validator are going quite well, and we have a tool for everyone to check that out.
Yeah, great. And I guess as a side comment from my side, it's an incredibly valuable tool set to support at-home validators who are using cloud providers to stop building reliance on a single potential source of failure and centralization, right? Because enabling for multi-cloud provider redundancy is obviously a critical component, and one that kind of ties into the rest of the use cases that we'll have as part of the discussion today. Cool. Any other thoughts or comments on how at-home validators can be using this tool, or should we move on to the next one?
I will add something which is maybe a bit further into the future, but you could have a group of friends validating together, holding up a few validators and splitting the keys between them, and also splitting up, just being more robust, or more redundant, and so on. So that's another possibility. Or maybe a small community, like 10, 12 people, and so on and so forth.
Yeah, I actually think that's very valid, and that's a very good way to use secret shared validators.
Great. So would love to segue, now that we have especially Alon and Collin on the call. We've spent quite a lot of time thinking about trustless and decentralized staking pools around, how SSVs can be leveraged for that kind of configuration. And interestingly enough, when kind of this research group formed in the summer of last year, we were pretty heavily focused on exploring the at-home validator and staking provider use case, but it looks like there's specifically some great benefits to this type of configuration for decentralized staking pools. And with that, would love to hand it over to you, Alon, and then over to Collin to kind of hear your guys' perspective on what the value add is of this kind of setup.
I think the biggest challenge for staking pools is how do you make it so that it's secure, it's decentralized, and you're reducing as much as you can the slashing risk. One of the key components of decentralized staking pools is the socializing both the risks but also the rewards. You know, unless you're losing, everyone is okay-ish splitting up the rewards. But of course, if a massive slashing event happens, if you are you know, the only operator in the staking pool, or if the staking pool has multiple operators, they're all still have the same common issue, which is they're all running the same single validator per private key, or multiple private keys in one validator client. And if that gets compromised, then or compromised or has some downtime, then everyone loses. And so, you know, in a big network, you're only as strong as your weakest operator. And so I think in that regard, the central SSV can really help the centralized pools, because you can take several, well-known or centralized services, and if you build up them into an SSV, let's say, group or SSV network, which all of the validator, all the pools are run by them, you can take several trusted entities, but become a trustless network, because they don't need to trust one another to operate. And one or two or up to the threshold can actually get compromised without compromising the network. And that makes a much more robust decentralized pools solution. Because the withdrawal side, we already see there's some good solution to it, but the operational side of actually running the operator is still very much, I think, needs a much more robust solution. So SSV, I think, could play a major role in that, really reducing the risks of slashing in a pool setup, but also just, you know, uptime. You know, if you think about a big operator running a pool, you know, downtime for maintenance, downtime due to errors and bugs, slashing due to errors and bugs, and so on and so forth. All of those things can greatly be reduced by SSV.
I would say I'll kind of start with the way I've looked at it is like, how can this be used today? And then we can talk a little bit about what I think it could be used for in the future, which is similar to what we just discussed. But like today, if we look at like the most prominent staking pool that's inside of ETH2, there are, I believe, 5 different single operators inside of that network. All users who stake into that pool are susceptible to single operator failure. SSV doesn't necessarily in the short term will fix single operator failure, but what it allows these providers in the pool to do is like further secure themselves. And that's important for 2 main reasons. One is it's important for the provider, because today, like the most prominent staking pool is not one that you gain entry into because of economic means. It is one that you gain access to due to reputation and, to be quite frank, centralized voting. So if you're a provider and you're in this pool and you're one of the only ones that creates a slashable offense, which is tracked inside of these protocols, everyone is going to know that it's you. This then results in you getting voted out of the pool and potentially not getting voted back in the pool because your reputation is the basis of your access to provide infrastructure to that staking pool. So I think that for those providers today, it's very important for them to like help protect their reputations, because if you're running a trusted staking pool, then as a trusted provider, like you actually put yourself at risk by, you know, you could hurt your reputation. And if there are other staking pools for other networks that have some type of DAO voting in mechanism, then it also hurts your chances over there. So I think for them, like today, to like begin figuring out like how do we protect ourselves from getting voted out of this cash flow stream, I think that's really important. For users, it's also important because when staking into a staking pool, if you use under 32 ETH, you will mathematically most likely get stuck with one provider. If you deposit more than 32 ETH, there's a good chance, well, it's a known chance that you will at least be diversified in your stake amongst providers. So if you're in that situation where your stake is still always going to a single entity, you're going to want that entity to have some type of further protection against some of the most common things that we've seen slashed today. and that is due to one, being locked in this environment today. It's very important. Not all staking pools you're locked into, but when it comes to the single operator failure, it's something that you're kind of just, stuck with. Another key component of this is like how these pools insure themselves. Today, these pools are insuring themselves through external means based on deposits. The insurance element of this is, in my opinion, today, at least a bit shaky. I don't necessarily know how the payout process, I don't think it'll go smoothly if there is some type of slashing event inside of a staking pool. And on top of that, I don't think we've seen what could happen with correlated slashing inside of a staking pool. I don't think it's, uncommon to think that these providers are all running very similar setups. Or like degrees of the same level of setup. So I think that's also something that users should keep in mind when exploring pools. So it's important for the operators to keep the cash flow stream. It's also important for the users to help protect them, because today these different types of insurance mechanisms that exist aren't really tested. So you can get a higher degree of self-insurance, if you will, by forcing validators or partitioning validators in a staking pool to use an SSV setup, even if it's single operator based today. In the future, there's loads of different things that can be done with this. The hope and mission is to divide signing rights amongst unknown parties so that they can act trustlessly. I think it's going to take a while for us to get there. I also think that, building off of SSV, there's this opportunity to build new incentive models around collaborative work behavior. Today, again, like the biggest question has been, well, what is the increased cost for me to provide this product to my customers? Do my customers notice, or can they assign value to like the increase in security and how it protects me? And today, these are not very well understood things. But if we can get multiple people to collaborate together and then use incentive models to ensure everyone is acting healthy together, that's really kind of the progressive path of like how we can get to a trustless environment where people are working together that hopefully aren't voted in based on trust. So sorry, that was kind of a long answer, but it's, this is ultimately an opportunity that like opens up a whole greenfield area of like what can different staking products look like. And it'll even allow for someone from home, right, to have more confidence to participate in a decentralized pool in the future because they have more confidence in their setup, if you will, as well. So it trickles down the whole stack of different validators, and the road ahead is quite bright, but it is also a long road.
Maybe to add to that, it adds the opportunity to build your own pool, like for you to say, I want to stake 32 ETH and I will select the N different providers that I'm going to put in that I trust most. I think that's a very interesting setup. It doesn't have to be providers, it could be clouds as well. Like I don't like the idea that ETH2 in the end would run all on Amazon, but if instead many people will decide, I mean, we know this will always happen, right? Some people will always run their validators in the cloud, but if at least they can decide to run it in as an SSV between Google, Amazon, and maybe some others, then that will already be a huge gain.
I want to add a factor, but which is not talked often, but the bigger the single point of failure is, the bigger the actual penalties could be. Built into the ETH2 protocol is kind of an escalation feature where if you have a bunch of validators all slashed together, the actual penalty grows quite significantly. And that's a major factor to take into consideration, because most of the time what you do is, if you are a retail staker, you'll go to the big guys and try to stake there, just because of your reputation and so on. But you also carry a much larger risk. So being slashed alone in your home setup is much different than being slashed in a by a big service with, let's say, 5,000 or 7,000 validators. The penalties will be different. And so I always kind of take that into consideration, because I see Ethereum 2 as a low risk, low reward kind of instrument in the best intention in the world. I do think low risk, low reward is something the industry in the whole needs. And so if you pump up the risk by using a service which carries a more risk because it's centralized or so on and so forth, then it also shifts the economical incentives for actually staking. So that's another thing to consider.
Since we are on the topic of use cases and motivations, I wanted to add there are different motivations for SSVs. I think Dankrad first got interested in SSVs because it allows to increase security by splitting your keys. I got interested in them because purely from a performance perspective, it allows us to build something that never misses an attestation or never misses a block proposal. Alon got interested because it allows for decentralized staking pools, trustless staking pools. And there are lots of implications for cloud staking products and the relationship between staking providers and their customers. So really, this is a powerful tool, and it's a game-changing technology. And I don't think any other blockchain community is thinking about anything that comes close to this.
100% Aditya, and totally agree. I think this is a really fundamental innovation, and I'm super duper thrilled to be part of the team to move this forward. Any other comments on staking pools that you guys want to surface? Any parts of the conversations you want to highlight? Let me know. Otherwise, we can kind of move on to the next topic. All right. So we've kind of touched on this. I'll give my background. I became interested in this effort because I kind of took on, and I'm just going to take my moderation hat off here, because of really the potential that I see for this type of solution in like infrastructure and staking provider type configurations. I'll kind of give like a little bit of background from my side before I ping it over to the rest of the group on comments and feedback. But as of today, kind of best practice when you think about staking providers that are servicing both retail and institutional customers is that redundancy, for the purposes of really mitigating operative risk and correlated slashing risk, redundancy is a critical component of this. So if you look at configurations that exist in the market today, there's often existing configurations for like multi-cloud and multi-region redundancy across different clients. But I think like one of the areas that I want to highlight here is that this redundancy configuration in many ways is an active passive redundancy configuration. So there aren't two nodes synchronously creating an active type redundancy setup. As it works today, there's kind of like backup nodes that service as a failover in case a primary node fails to perform its duties. And kind of the nuance with this is that in the existing topology of how the architecture on the base layer is built out, achieving complete redundancy at the level of the client is actually something that's very hard to do, because beacon nodes are configured to talk to certain validator clients. So having an active failover between different operated validator clients is actually something really hard to do. So I think one of the areas that got me predominantly most excited is that this really creates an opportunity to, in a really low scope way, implement a configuration that has superior redundancy opportunity across pretty much all of the core components that comprise an infrastructure setup for a provider, which is a massive value add for customers. And that's something that, especially for providers that operate at scale, doesn't just have a risk benefit, it also doesn't introduce a massive amount of operative costs. So it's almost like a win-win for a configuration that drives significantly better resiliency without introducing a significant amount of overhead for the deployment. So that's kind of my perspective on this. I think this is extremely valuable in the context of, you know, how providers may think about the future of their infrastructure setups. I also think it's critically important considering if we look at the landscape of players on you know, the playing field of stakers, there are a lot of very large customers, exchanges, custodians, people who have like what you could call critical mass in voting power in the network. And one of the things that I think this really drives is the potential to enable customers of other providers to have a pre-configured set that introduces diversification. And what I mean with that is enabling configurations between different providers to service the diversification and risk diversification needs of other customers, instead of requiring integration cost of working with a new provider, instead of requiring the things that like are a very high lift for customers to work through, but can really be, you know, implemented at scale and very easily through an existing middleware solution that makes that possible. So putting my moderation hat back on, this is kind of what I wanted to add into the mix, but maybe I'll ping it over to you guys and see if you have any other thoughts or comments on this.
Yeah, I would add that even you've talked about redundancy in terms of operational cost, but if we take redundancy or the way SSV is set up in terms of development cost or development risk and cost, that reduces that significantly as well. If you have a single point where somebody can do something which brings the whole system down or gets a bunch of validators slashed, which current setups do have, like literally it's a single validator client which runs those validators, then the actual development costs and risks are very, very high. And what you'll see are bottlenecks inside the development team. If you have a single component which is really, really sensitive, then it means that very few people can touch it, very few people can change it, and that adds a lot of risks. And so if you have an SSV even from development point of view, you can have much easier life because, you know, if you split up your sensitive key holding and key signature points into various nodes, then all of a sudden changing something is not terribly terrifying, because, you know, if something doesn't go well, you can revert back and you don't have to do it across all of the nodes. You can do it across one and it's still resilient and still fault tolerant and so on and so forth. So I think that's a major improvement as well in terms of just, you know, development and progress within actually any service which develops something on top of staking.
From the perspective of like competitive dynamics, this is something I've found to recently become quite interesting. So like watching this whole thing develop and doing loads of research into like, do you want to stake? Do you want to offer services? And spending time talking to token holders and providers for like many months, and like trying to guesstimate like what are the competitive dynamics of this industry going to look like once it actually launches. So now that the Beacon chain is launched and people have made their like initial deposit decisions, and we've seen the different product configurations and, you know, the different stuff that the people have brought to the market, if you will. Inside of the largest validator space, the institutional validators, the largest network operators, there's going to always be a set of like KPIs. I believe that like offering infrastructure at that level should and will become a commoditized type thing. I think it's healthier if these businesses become moderately commoditized, but again, if they are, which they're becoming so, not just in ETH2, but elsewhere, they will attract deposits, which has a dependency, right, on centralization or decentralization of stake for different reasons. Today, what we've seen is like one of the main KPIs being is like, you know, what is my effectiveness and how close is it to 100%? We've recently seen a validator kind of push their system for liveness over safety. In response to like how the market has treated their product and like what the market demands from them. which is actually, pretty basic. There's a lot of things that people want, but at the end of the day, like, they want to make sure they are getting the most return possible. And when it comes down to ETH2 rewards, like, unless you're getting lucky and, whistleblowing, to get the best rewards, you need to be as close to 100% as possible. So to Aditya's comments about like the potential for this to create hyper performance from a mature perspective, I think it's like really healthy for the competitive dynamics of the industry. Whereas if we can allow, if this piece of middleware essentially allows for the entire industry to kind of up their performance without sacrificing safety, I think it's quite healthy. And it helps commoditize their offerings based, and there'll be new KPIs tomorrow for these things, but I think Secret Shared Validators is actually kind of a long-term way to like help neutralize the competitive dynamics in that industry and actually introduce more safety for everyone, which I think, again, if we think that stake is going to slightly centralize over time, we want to make sure that if that is happening, that the biggest providers are using tools that like help protect the whole network, because the last thing we want to do is see a big provider have a huge correlated slashing event and then have all their validators exited from the chain. And maybe that results in some type of security compromising situation for the whole network. These are black swan type events, but ultimately I think the competitive dynamics of the institutional space through SSV being included will like create a new choice mechanism for depositors, which is quite interesting.
I also think that we saw similar developments in hot and cold store wallets after the big, 2013 hacks and into exchanges. What we saw was the separation of hot and cold storage wallets, and then the cold wallets were really innovative in multi-party computation and making sure the keys cannot get out and access control and all of those things, which is in some ways similar to what SSV is. The big thing with SSV is that all of your keys are, or at least the validation keys, are always hot. They're always online, and that's a major thing. And so, we saw that previously, innovation on the way you keep your keys safe and live. We saw tremendous development back in the exchanges and institutional custodians, and we'll see the same thing here, which is interesting. And I definitely agree. I think that hopefully that will become a standard, and maybe also a way to actually externalize your safety measures and safety setup.
Great. I realize we're getting close to time, so I kind of want to navigate the conversation in the direction of hearing a little bit about the progress of the development roadmap. What are the key milestones, and how can people at home get involved with this?
So we actually have a community call next week, and I really, encourage everyone to join in. We'll really focus on what we did until now and obviously where we're going. We did a lot of work the past few months, taking a proof of concept we did back in 2020 and bringing it up to maybe a more production ready project. And the goal here now, and we also have a running testnet validator, which is operated by an SSV group. And the next big milestone is really some kind of a testnet. Basically, having a few validators run on the Pyramid testnet, but behind them all operationally working on an SSV nodes. And the key there, I think, is having diversity in terms of who is actually running the nodes, right? As of now, the test node we're running is we just put it on our staging environment and it runs there, but obviously it's not a real world setup. And so to start testing latency, to start testing efficiency, to start testing scale, and so on and so forth, we really need to set up a good testnet and have as many partners as we can join in, and each one of them testing out and from deployment all the way to actually operating a node. And so I think that's the big milestone we're getting into. And so in terms of getting involved, definitely, I think two fronts. One is active development and testing. That's one aspect of it, and the second one is really contributing to the testnet itself. Just a way to get just get those SSV nodes running and set up and see them in action. So those are kind of my 2 cents on that.
Collin, I know you've been doing some work on testnet coordination. Are there any things you are kind of ready to share about this, or should we save this for next week's community call?
It's probably best for next week, but to Alon's comments, like, we're all aligned that diversity is great. Right now, kind of what I have etched out is like a 10-day go at it where everyone deploys and operates. And if we can get like healthy representations across at-home, institutional, staking pool providers, institutional and staking pool providers, you could kind of call, the same individuals in this, but having a healthy mix of both, I think would really be great. And again, as the technology has such like broad use cases, we want the testnet to be broad as well. So like we have a core group of people that we'd love to participate from a knowledge perspective, but I would love to get some at-home validators involved for that too, that have built their own custom setup, that may know tricks and can add value to its testing. So looking forward to updating everyone on that next week on the community call.
Awesome. Great. So the last few minutes to wrap this up, I'll just give a quick overview of, general channels where you can get involved. So we're under the ETH2 or the general ETH R&D channel on Discord. So just pop in there, Secret Shared Validators as a sub-channel, so you can always stay up to date there. Please feel free to add any comments in the Discord. It also links back to a Twitter connection, so you can always communicate with the team there. And following this call, just keep your eyes peeled for the live stream link if you missed this. And we'll be circulating some additional materials for next week's community call, so you can RSVP to join that conversation. And thanks everyone on the call for joining in the conversation today. Any closing remarks, let me know, but I thought this went great, and looking forward to connecting with all of you next week.
Thank you.
Thanks.
See you, everyone.
Thanks.
And we are officially offline and not streaming. That went really great, I think.
Yeah, that was good. I think moderation helps. I was a bit concerned that it would be hard to coordinate without kind of navigating the conversation, but that was like super great. So yeah, really appreciate it. And we actually had quite a few people tuned in.
I recorded the whole conversation, so I'll circle back the video if anyone wants to, I don't know, have it and cut it and do whatever they want with it. And it will also be on YouTube. Yeah. Awesome.
Awesome. Good stuff, everyone.
Thank you. Bye-bye.
Bye.
Quick follow-up question. The live stream link, it's just going to replay, right? So no reason to use a new one.
So yeah, it's actually the first time, but I think I just need to hit publish or something, or it's already published. Yeah.
It is published. Okay, cool. Let me circulate this around as well with our email list to make sure for those who